Hi, everyone. Welcome back to New York Energy Week 2024, the epicenter of global energy innovation, where industry leaders, visionaries, and pioneers gather to shape the future. This landmark event, now in its 11th year, unites the brightest minds to forge new paths and challenges to the conventional boundaries of energy, technology, and sustainability. So thank you for joining us here on the One Business World platform for our transformative journey that promises to inspire, empower, and catalyze groundbreaking advancements in the energy sector. So joining us this afternoon, next up on the program from Connecticut is Tony Abate. He is the Chief Technology Officer of Atmos Air Solutions, and his topic is the paradox between decarbonization and indoor air quality and using technology to solve the dilemma. Good afternoon, Tony. Welcome.
Good afternoon, Len. Thank you very much. I appreciate the opportunity to present this to the audience. This presentation I'm going to deliver was actually based upon a white paper that I wrote, which was accepted and published by ASHRAE, which contains a lot of subject matter regarding decarbonization and things that could be done to help provide more efficient and sustainable built environments. As we can see, decarbonization simply means the reduction of carbon. We know that carbon dioxide is emitted from the burning of fossil fuels, creating that greenhouse gas effect, trapping heat in the atmosphere. We've kind of created a dome around our planet. It's becoming warmer, and we've seen that the climate change is real, and there's potentially very adverse impacts as a result. In the United States, our commercial buildings, account for 40% of all the energy that's consumed. Within the building, 38% of the energy is consumed for heating and cooling, for making spaces comfortable. That actually equals 12% of total U.S. energy consumption. But the problem is only 20% of electricity in the U.S. is renewable. Also, natural gas, which is a major source of energy in our commercial buildings, is also non-renewable. So we're using a lot of energy in our buildings to keep the spaces comfortable for heating and ventilation and air conditioning. We're using a lot of non-renewable energy as a result. Ventilation is a very important aspect to providing good indoor air quality. And the engineering society called ASHRAE has provided guidance and standards requirements for correct ventilation. Back in 2020, as the pandemic dawned upon us, ASHRAE formed a task force to look at recommendations to what should be done that could help stop the spread of airborne illness. The recommendations were to increase outdoor ventilation and increase filter efficiencies in buildings. Now, yes, these measures will improve indoor air quality. However, they will increase energy usage. More efficient filters are harder to get the air to pass through them. And of course, outside air needs to be heated and cooled and dehumidified to be comfortable. So let's talk a little bit about filtration for a minute. Many people may not understand exactly what filters don't and can and cannot do. Media filtration, which is the most common form, is a passive air cleaning method. What I mean by that is the contaminant must be brought to the filter to be effective, so that the dirty air has to kind of be delivered to the filter. The filter captures contaminants and kind of then dilutes the air with cleaner air. So it's very dependent on air exchange, on the recirculation and the ventilation within the space. Now, most of our buildings are designed to 2 to 3 air changes per hour. This is really done for 2 reasons: comfort and energy efficiency. But if I were designing a building to optimize indoor air quality, we would use 6 to 12 air changes per hour, quite a bit more air changes, which would again increase energy use significantly. And to kind of understand a little bit about what happens to contaminants, a group in Ithaca, New York called Holt Architects performed this simulation. It was based around coughing and sneezing, certainly during the pandemic time. What happens when someone coughs, sneezes in an occupied space? They did this in cooperation with a group called ME Engineers. And it showed that in a typical office environment where you have cubicles on the interior and offices on the perimeter, with normal ventilation and MERV 13, which is a high efficiency grade of filtration. Um, when someone coughs or sneezes, those droplets spread horizontally. They kind of impinge upon the other occupants uh, way before they would then be caught up in some sort of filter, and the majority never got to the filter. So it goes to show you again what the filters are limited in what they can do. And this is an interesting simulation. If anybody in the audience is interested, just Google Holt Architects COVID simulation, and you can see the entire simulation on a live stream. So technology that we've developed, though, can provide solutions to this dilemma. There are many active air cleaning technologies. And what I mean by active air cleaning, those are technologies that can produce an effect that goes into the occupied space that then can attack the contaminants at their source. These then are not dependent upon airflow or increasing outside air and increasing conditioning costs. So therefore, not increasing energy consumption. There are many different of these technologies. One I'm very familiar with is dielectric barrier discharge, which is the technology behind the atmosphere technology. And there are others as well, UV technology, dry hydrogen peroxide, and photocatalytic oxidation. They all work on different principles of operation. UVGI uses germicidal UV to disinfect microorganisms that pass through a light field. UV systems can be very effective at sterilizing surfaces that the UV light comes in contact with, less effective on an airstream. PCO, or photocatalytic oxidation, uses UV light to form a reactive element called the hydroxyl radical that can help disinfect microorganisms, but it's limited only to microorganisms and doesn't have a very long reach. Dry hydrogen peroxide actually produces peroxides that can go into the air in a dry form. Again, effective against microorganisms, less effective against other contaminants. The atmospheric technology, dielectric barrier discharge, produces bipolar ions, which actually are something that are produced in nature, that the system then increases in indoor environments, which then takes these ions, precipitates them throughout the space, and they can do many things like agglomerate particles and drop them out of the air, break down VOC gases, which can produce odors and irritations, and then also disinfect microorganisms, again, going to the organism at its source and stopping its ability to reproduce. An active cleaning method that continuously goes to the source of the contaminant, doesn't rely on the contaminant to come back to the device. Now, when you're looking at any technology, what are some of the things you should look for? Well, one thing you want to know is that your technology is safe. And there are consensus safety standards, UL 867 and UL 2998. Any product that you buy that's electronic should be UL or ETL listed. That's one thing to look for, but you certainly want to look for the fact that they're listed to these standards. You want to know that the technology can be used in conjunction with the ASHRAE standards for ventilation, which also are corresponding to the International Mechanical Code standards for ventilation. And you also want to know that the product is effective and it's been tested independently. One thing unique to atmosphere technology was it was part of a study that was done by Fresno State University, which was actually sponsored by the San Joaquin chapter of ASHRAE. And what the study concluded was that when you combined ASHRAE dielectric barrier discharge ionization with a MERV 13 filter, it yielded performance similar to a HEPA filter. And one thing we know is that a HEPA filter is really the only filter that's efficient enough to capture a microorganism-sized particle, like a virus or a bacteria or a spore. But most buildings cannot use HEPA filtration because it's so highly restrictive. It will make the building almost impossible to condition without using dramatically more energy. But this combination can now take filtration that many buildings are already using and really increase it to that HEPA performance without increasing the energy usage. Also, in another study that was performed, at the New Rochelle, New York schools, which, if you think back to the early stages of the pandemic, New Rochelle, New York is one of the first towns that really locked down in response to the spread of COVID. The schools went ahead and decided to outfit all their schools with atmosphere technology, 97 separate areas in all, and they had an independent engineering firm test each and every area that was outfitted. And what the test showed in all areas were improvements to small particles, total volatile organic compounds, formaldehyde, increases in ion levels, and also no increases to ozone levels. Again, keeping with standards for performance and safety. And it's something to look for. You want to know that any technology you choose has been tested in the laboratory, but also been tested in the field and is effective in its intended use. One thing that I was a part of that happened about a year ago was the publishing of a standard called Standard 241, the control of infectious aerosols. U.S. government came to ASHRAE, again, on the heels of the pandemic, and said, we need guidance. We need a pathogen control standard for our building. So ASHRAE put a committee together, and we developed this standard. What the standard does is gives guidance to many types of indoor spaces on design and operational measures to minimize the spread of infectious aerosols. What's very different about this standard was the development of a term called equivalent clean air per person rates. Now, if you're familiar with ventilation codes, they're usually done in outdoor air per person rates. So in other words, most codes will require a certain amount of outdoor air per person to ensure a healthy space that optimizes indoor air quality. However, as we looked at developing the standard, we could see that air cleaning was every bit as important as outside air, and that very effective air cleaning was just as effective, if not more effective, than outdoor air. So that's why the standard requirements are in equivalent clean air per person. And now this really takes air cleaning into a sharp focus. Using effective air cleaning, which can improve air quality, ensure healthier and safer spaces for us all, but at the same time reduce energy use and carbon emissions. This could have a major impact in our buildings as far as decarbonization and getting to our net zero goals. And the atmospheric dielectric barrier discharge technology can be extremely beneficial in this strategy because it uses very little energy, does not restrict airflow, yields a high air cleaning performance, and allows a building to reduce its energy usage by using less restrictive filters, by reducing outside air, all of things which will use energy that ultimately may come from fossil fuels. Another thing about our buildings is kind of interesting. I would bet that everybody that's listening to this now has a smartphone, but only 13% of our buildings have a central automation system. So most of our buildings are not very smart. They need to get smarter. The one thing that's I see coming very much so in recent years is the age of awareness. And our buildings are becoming more aware of what's going on around them, and air quality has become something that occupants of buildings are asking for on a regular basis. People want to know what they're breathing in. So indoor air quality monitoring is becoming very widely used. There are sustainability standards that exist. There is the USGBC LEED standard, the International Well Building Institute Well Certified standard. There's a group called Fitwell, and also a group called Reset. And in each one of these building standards, indoor air quality monitoring is a requirement. So again, applying indoor air quality monitors, getting data about your air quality can help you not only be aware of what's going on in your building, but also validate successful outcomes. If you've taken strategies to improve air quality, if you've taken strategies to reduce energy usage, use of these monitors can kind of tell you if you've been successful in your strategy. And here's an excerpt from a study that was done that showed how you can decarbonize on a wide scale. This was done in a major sports arena where atmospheric dielectric barrier discharge and air monitoring were used throughout the arena, which really the goal was to reduce energy use and carbon emission. There really were no perceived or known air qualities in this large arena. The atmospheric air cleaning allowed for reductions of outside air of 50%. And also, the arena previously had used a two-stage filtration method, which had a MERV 13 final filter and a MERV 8 pre-filter. And because of the atmosphere's air cleaning ability, the second stage of filters were completely eliminated. Now, to ensure that the air quality was not affected by these changes, the IQ was monitored by use of 40 atmosphere-aware space monitors that were dotted all around the stadium, concourses, all sorts of areas from in the best seats in the house to the highest seats in the house, and showed that air quality remained very good throughout all areas of the stadium. But then how did this impact energy use? Well, the energy use was compared to baseline from a year before using an accepted standard, the International Performance Measurement and Verification Protocol. Some here may be familiar with that. And it used the whole building method, which is called option C and D. And that's basically a method where you take all of the factors and normalize them. So you're taking all the variability and you're looking at the impact of the change that you made from a baseline to current. And so what it showed after 1 year of operation was that the savings were 2,643,189 kilowatt hours. And this translates into a reduction of 1,880 metric tons of CO2. So a very significant impact in both energy use and also carbon emissions. And I will say that this was done 5 years ago. In each one of those 5 years, these savings I not only maintained, but actually increased. And of course, these savings translate into real dollars. And as we know, a lot of our energy costs have increased as time's gone on. So the dollars savings have become pretty significant. So overall, it shows that you can take technology, actually improve air quality, and realize savings in both energy and carbon emissions. That'll kind of bring us to our conclusion slide. As we discussed, burning of fossil fuels has contributed to that greenhouse gas effect, and we know that there's potentially very disastrous effects that can occur because of this. Most of our buildings are using energy from non-renewable sources, and conditioning in the buildings are a major source of energy use. Improving indoor air quality, traditional methods, such as using outside air and increasing filter efficiency, will cause more energy to be used and more carbon emissions. But technology options can help clean up air effectively while not causing more energy use. Again, one technology, the atmospheric dielectric barrier discharge bipolar ionization, has demonstrated through studies the ability to clean air while reducing energy use and carbon emissions. ASHRAE Standard 241 recognizes equivalent clean air per person as an option to increase outside air to control infectious aerosols. Again, effective air cleaning can be used rather than outside air. And again, using air quality monitoring can, again, track, measure the successful outcome of any strategy that you employ. So again, just to show you on screen, this paper was based upon lots of research that was tabulated. And that brings me to the end of my presentation. I certainly would love to entertain any questions that anybody might have.
Thank you, Tony. Nice job. Congratulations on the white paper being published, as well as the case study on the arena air and filtration. That's impressive credentials to have. So thank you for that. I forgot about New Rochelle being one of the earliest lockdowns. Being here in the you and I being here in the, let's call it the metropolitan New York area, I had actually I forgot about that. So that was an interesting piece. Hey, you know what I found interesting, given the age we're in, and you referenced it with the smartphones, the fact that we're not monitoring, it's, you would think we'd be all over that, that it would be constant. Like you would know for, oh, wait a minute, the air quality is down even a little back 13% only, huh? On that to me is kind of a shocking statistic.
It really is. It really did open my eyes, but it's understandable. As you know, I'm very involved in ASHRAE and all manner of committees and groups that develop standards for engineering practices. And one of the things that's very prevalent is the fact that engineering standards are developed to design buildings, hoping for a good result. But many buildings are not monitoring to understand if they're getting that result. And that's what we really need to get to. Our buildings have to get smarter. And I think they will, mainly because the people that are in buildings now, they're demanding it.
They're demanding
Um,
it. Yeah. Yeah.
I mean, we all know what companies are doing to get people back to the office. And so, again, telling me you're in a safe, healthy environment, and hey, I'm going to show you this. And, we have a lot of clients that have bought our monitoring systems mainly because they want to show their people that they're breathing clean air.
It's there's like a compact, right, between the company and the employee. This is a way of then, from a well-being standpoint, you think of like a public health type of situation. This is a way of kind of demonstrating that. I know, during, as you mentioned, during the pandemic, we all had lockdowns. I'm on the board of a museum out here on Long Island. We were shut down by the county almost overnight, like everybody else. And the only reason we could even reopen on a limited basis some 6 or 8 months later was the air filtration system had to be upgraded and improved, and we had to demonstrate that we had those capabilities. Interesting though, and I guess I never really focused on it, but it makes sense, the difference between passive and active from a solution standpoint, waiting for it to come to the cleaner or having it go out and grab it, right? Most of our systems, are they more passive or active, or are we seeing more of a shift to active?
Well, traditionally, most of the air cleaning systems are passive. I mean, filtration is the most time honored, widely used form of air purification. But we are seeing a shift. And I'll kind of mention something that happened about a year ago. October 23, if you recall, 60 Minutes did a piece on indoor air quality. They featured a fellow by the name of Professor Joe Allen. And in that, they were talking about a survey that was done, which asked respondents, in response to the pandemic, what are some of the things you did in your building? And the number two response was, we implemented bipolar ionization. So it kind of shows how buildings and how our marketplace is kind of understanding we need active air cleaning. We still need passive air cleaning. You have to catch it and grab it, but you got to go out and get it as well. And it's seatbelt and the airbags. You
Yeah.
need
Yeah.
layers. Always make things work better.
Some of the early stats you had out there. I mean, buildings, 40% of all energy consumption, the HVAC, 38% of that, so 12% in its entirety. These are big numbers. I mean, so being on top of it, being able to be nimble and proactive with it, and getting systems in like yours would seem to be certainly valuable. How about Tony, your experience? Tougher to retrofit? Would you rather be upfront as part of the initial construction design? How does it work? Are you your system? I assume can go either way. But I mean, what's been your experience? Are you there at the beginning as they do the design and the build, or is it more coming in and again, we're looking at New York City where the stuff may be decades old already.
Mhm. Well, I mean, we serve both markets for sure. We do a lot of design build work where we're specified by consulting engineers, but we have a large retrofit demand as well. And one of the nice things about an active air cleaning system, different from a passive air cleaning system, because you're not designing the mechanical system to fit the air cleaning system, but rather the air cleaning system adapts to the mechanical system. With active air cleaning, like our bipolar ion technology, you don't need to make any engineering considerations for it, so you can retrofit it as easily as you could design it in. But if you're talking about, let's say, a filtration system, you may need to change airflows, duct sizes, a lot of things to accommodate it. Not so easy to retrofit.
No, 100%, 100%. I'm sitting here. We have our own air conditioning thing coming tomorrow because sad to say, some of the ventilation hasn't been going well here. My wife is like, "What is this? What is this?" I said, "I don't know. Let's wipe it up. Let's get them back tomorrow to fix it." Listen, Tony, thank you. Really interesting presentation. A lot of stuff that those of us that you all right, as you said, people getting companies getting people back to the office, stuff that you may take for granted, but now coming out of the pandemic, having a smartphone type of information technology kind of everybody wants data now. It just a lot of things we take for granted, but thank you for bringing it to the forefront, reminding us how important it is, and thanks for your good work in this area.
It's my pleasure, Glenn. Thank you for the opportunity to present this. And certainly, look forward to doing more. I think there's a lot we can do to make our buildings more sustainable, to make our planet more sustainable, but at the same time, make ourselves be able to live in a healthier environment. And I think we just have to keep, trying our best to do that.
Well, thanks for all your leadership here in this space and in moving towards and getting us healthy for sure.
Thank you again.
Thank you, Tony. Have a good rest of your day.
As well.
Take care. Bye.